method. So actually, they do not represent the market, but we pretend that they represent the market. So we go further. Now, this is my data. You know that already. I based on lecturers. It means that the perception of students on their lecturers, subject complexity, rationality of curriculum's length, facility, career development, location, environment, and satisfaction. 1, 2, 3, 4, 5, 6, 7. 7 dimensions. You see all of them are in people's mind. For example, lecturers here is not the real lecturers of the universities. Example here, lecturers is 3.3333. This one is not the real lecturers of FTU, but it's the perception of this student. It's called FTU1. Okay, perception of this student on the lecturers of FTU. This one, for example, the same thing, lecturers of someone from FTU. Okay, this one is the perception of that person on the lecturers. Okay, and the same thing for facility. So that's why you see facility too. So those are just in people. Okay, satisfaction is also in people's mind. So 7 dimensions in people's mind. Now we use those things to do the segmentation. But the first question we must answer in the segmentation is that how many parts should we divide this market into, right? How many parts? We segment the students, that's right. Okay, but into how many groups, right? Into how many groups, we don't know. So if we don't know that, we do the cluster technique that is called hierarchical clustering. Okay, how to do that? You go to analyze, and clustering is in classify. See, hierarchical cluster. This one is to answer how many segments should you have. Click it. And because I use those 7 dimensions in people's mind, so I put on 7 of them into variables here. Easy. Then click the statistic. We will use agglomeration schedule. So what is agglomeration schedule, right? Agglomeration schedule is like this. Agglomeration schedule. Now let's say that this one is a respondent. How many? Yeah. And the distribution of those respondents are like this. Yeah, I have 10 of them. Now let's say that I have 10 of them. Okay, like this. That's how they distribute in the space of 2 dimensions. You can see. Okay, 10 of them. So agglomeration schedule is like this. At first, with 10 respondents distributed like this, SBS will think that you have 10 segments. Okay, 10 segments. And then after that, SBS will group the 2 nearest of them together into a bigger segment. No, this one is, yeah, that's the green and send to back, right? No. Now to send to back. Not here. Okay. group two of them, the nearest, into hey, how can I send to here, send to back. Okay, into a bigger segment. Now after the first step, we will have 19 segments, right? Oh no, 10. Then we have now 9 segments, and then after that, SBS will group the next nearest here. That's the second step. After the second step, we will have 8 segments, and then the two nearest will be grouped together until we have only one big segment. Okay, and then after grouping like that, it will show you the size to decide which one is the best number of segments. Okay. Of course, how many segments is your choice. No. Where is my SPS? Not here anymore. Cannot share anymore. Why? Must go out and get in again, huh? That's right. Okay. That's agglomeration. So make sure that you check the agglomeration schedule, okay? Next thing, you click the plot and click the dendrogram. Okay. What is a dendrogram? I will show you later. And then click in the method, and you use the wax method. Okay. Wax method. What is the wax method? Is the best method that is in your book. Wax method is based on variance, and measure. Make sure it's interval. Why is interval? Because you can see that on 7 variables I put into the hierarchical cluster analysis, all of them are interval. So we click interval. And here we have square Euclidean distance. What is a square Euclidean distance? Well, I think you know about Euclid already, right? Yeah, already learned something about Euclid. Square Euclidean distance is how SBS calculate the distance between your respondents. Okay, how to calculate it? For example, here we have 2 of them. How to know the distance between them? Let's go Mr. A and Mr. B, right? Okay, how to know the distance between them? You know that they all have their coordination, right? With x1 and then x2. Let's call this x. To calculate the distance between Mr. A and Mr. B in this x and y coordination, then you know that already, right? It's the square root of something like 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 this. Writing on the board is very easy, but you don't have the board. Yeah, see, the distance between A and B is the square root of yeah, xa minus xb, xa minus xb, and this one should be a square, right? That's, and then plus ya minus yb on square 2. And all of them you get square root. This one is like Pythagoras, right? Yeah, it's called the Euclidean. But no, it's not this easy because this one only 2 dimensions, right? But in my case, remember, I have 7 dimensions. But the same thing is applied. Yeah, the square root of something like this. Ya minus yb. Yeah, okay. Square. You know this already in high school. It's called square Euclidean distance. Okay. So you know the method you use. Okay, do not standardize. Okay, yeah. Then you click OK. Now I'll show you the result and how to read the result. Okay, cluster. Now I told you already about the agglomeration schedule. So this one is called the agglomeration schedule. You can see that in stage 1. Yeah, first step, the cluster combine. In the first step, SPS will combine the respondent number 549 and number 555. And the coefficients here is the distance between them. The distance between them is 0. Now, why is this 0? Because they are in the same spot, okay? Those two answer the same numbers for the same questions. So that's why coefficient 0 here. Stage 2, yeah, the same thing happened with number 525 and number 533. They have the same answers, so coefficients is 0. Yeah, until here you can see that after 15 steps of combination of the same answers, then see in the 16th step, then number 32 and number 108, they are a little bit different. So the coefficient jump a little bit, you can see that. And then here in 7th step, jump further. Oh my God, I have 623 respondents in my sample. So a lot of steps happen here. The last step is called 622. Now, what are we looking for in this table? You are looking for the biggest jump in biggest jump in the coefficient, okay? And you always go from the end of the table and go up. Look for the biggest jump in coefficient. You can see that in between step of 621 and 622, between them, the coefficient jump up, let's say 800, right? 800 from 2 to 81, jump into 3083, so around 800. How about the next step? In the next step, it jump only, okay, less than 300. Remember, in the last step is 800. Next up, last step, only, yeah, less than 300. And then next up it, only around 200. So yeah, less than 200. So let's say that the last jump is the biggest. Yeah, 800 in coefficient. What does it mean? It means that Yeah, remember after the last step, we have only one cluster left. So it means that the next of the last step is where we stop. Okay. And where we stop, we have two clusters left. Yeah. Last step, we have one left. Next up, last step, we have two clusters left. So the best number is two clusters because they are farthest to each other. Okay. But this table is very hard to decipher. So another way easier, you use the dendrogram. I'll show you how to use the dendrogram. Yeah, the first thing I must make your dendrogram easier to look. So I usually use the chart size. Make it 500 multiplied by 500. Will be easier to look at. Here, this is the dendrogram. 500 is still a little bit big, right? But it's okay. Okay, how to use this dendrogram? I will print screen and put it in pen so I can draw for you. Or maybe not in pens, but in PowerPoint. Okay. Into PowerPoint. Now I show you the PowerPoint. Okay, this is the dendrogram. I cut it into PowerPoint. Look at the dendrogram. Now how to use this? This one show you the same thing like in the agglomeration schedule. It's how they combine the groups together. Okay. Now how to use this dendrogram and decide how many clusters we will have. Okay. Then if you want to use the dendrogram, see, you draw the lines like this. Whenever you see a vertical line, you draw the line into that vertical line. For example, this one is a vertical line. Here I have another vertical line. I draw a line. Now, there is another here. Okay. Normally, you just care about the longest in horizontal. Well, after you draw the vertical lines like this, you care about the longest in horizontal. Okay. Let's count this is 1. Let's count this part 2. And maybe we have part 3 here. Okay. Okay. Now you only care about the longest in horizontal. Part 1, part 2, and part 3. Which one have the longest in horizontal? Yeah, look at the horizontal. Part 1 is this long. From this to this. Part 2, this long. From this to this, and part 3, from this to this. So let's say that's in part 1, we have the longest horizontally. Okay. Now it's the longest, so we only care about part 1. And you will count how many lines you have. Yeah. Count them from the top to the bottom, 1 and 2. So we have 2 lines. If we have two lines in part 1, then the best number of your segments is 2. Okay, so with this data, we can divide into 2 segments is the best number according to SBS. Is that hard to understand? Is that hard to understand, people?
Yes.
Okay. Should I do that again?
Yes, please.
Yeah, okay. I'll do that again. Okay, what should we do with the dendrogram? Actually, it's very easy if you are familiar with that. Now, so this is a dendrogram. Yeah. Whenever you see a vertical line, you draw a line into it, okay, like this. Here we have another vertical line. Draw a line to it. Here we have another vertical line. Draw into it. Another one. You draw into it. Example, I want one more, then I draw here, right? Because here I have a vertical line. Yeah. Okay. Now let's count this part 1. Part 2. 3 here. 4 here. We don't care for the others because we only care the longest in horizontal. Okay. Part 1, part 2, part 3, part 4. Which part has the longest in horizontal? Okay. Look at the horizontal lines in part 1. It's very long. In part 2, yeah, it's very much shorter, you see. Part 3, yeah, even shorter. And part 4, part 4 is a little bit near to part 3, you see. But we don't care about part 2, part 3, part 4 because we only care about the longest in horizontal. Okay, so we only care about part 1. Now, talking about part 1, it's very long in horizontal. What does it mean? It means that the coefficient in grouping those clusters is highest. Okay. Refer back to the table before. Grouping the last 2 clusters, we have the biggest coefficient. It means that the last 2 clusters are farthest to each other. Okay, so that's why in the dendrogram, this part is the longest. Now we count from top to bottom how many lines we have. Yeah, from top to bottom. You can see that we have one line here and another line here in part 1. So 2 is the best number of clusters we should have. Now, why this is the best number? Because if we keep only 2 clusters, they are farthest to each other. See, they are farthest to each other. It means that they are the most different. Because here we can divide our sample into 3 clusters, right? It means that we have 3 segments, but they are not very different to each other in comparison to 2 of them. If we divide them into 2 segments, they are very, very different, you see. So if we divide into 3, 1, 2, 3 here, we use the part 2, then they are not very different because the length in horizontal, they are not very not very long in comparison to part 1. So 2 of them is the best number. Can you understand that? People? Oh, this is too hard. Oh my God. Teaching this in online is too hard. Okay, anyway, yeah. Why are you writing? Why don't you ask me with your mouth?
Can we compare the vertical gap?
Vertical gap. Yeah, I look at it. The vertical gap, right? Vertical gap. Gap between what and what, Vic A?
Between
Gap,
the
gap between the lines, right?
yes.
Yeah, gap between the lines. Then you can see that in part 2 here. Look at part 2. If you compare the gap between the lines, you have too many gaps to compare, see? And in part 3, 1 gap, 2 gap, 3 gap, and yeah, 4 gaps. You see a lot of gaps. How can you say which one is bigger, right? If you compare it with part 1. Part 1 only 1 gap here, part 2 2 gap, and part 3 4 gaps, and in part 4, yeah, even more. How can you compare between them? So many of them. So best way is to look at the horizontal line and yeah, compare to get the longest horizontal lines. Easier for you.
Okay, thank you, teacher.
Yeah, okay. So after we count, we can see that, yeah, SBS suggests to you that with this data, it's best to make 2 segments. So how to know about those 2 segments, right? Now we have the number, the best number of segments. The second thing to ask is about the characteristics of those segments, right? Okay, we divide the market into 2 segments, but what are the characteristics of those segments? Okay. So if you want to know the characteristic of those segments, you do not use the hierarchical cluster. Instead, you use the k-means. K-means here in classify, go k-means cluster. This one is called a quick cluster. Now, how to do this? You put on the 7 variables into variables, very easy. And number of clusters, yeah, the best is 2, right? So we keep it 2. And yeah, don't click the iterate, don't click the save, go to option. And yeah, okay, we do not need to click anything, just click OK. Okay. Now I'll show you the result. The output here. Do not look at the initial cluster center. We do not need it. Iteration history, we do not need it. Instead, you look at the final cluster centers. Now you can see that, yeah, we divided the sample into 2 clusters. Cluster 1, 350 people. Cluster 2, 273 people. Okay, but what are the characteristics of those people in the clusters, right? Then you look at this, the cluster centers. Okay. Now you can see that cluster 1 here we have, yeah, lecturers. The mean of the cluster of the lecturers, perception on lecturers in cluster 1 is 4.2. Subject complexity 3.9. Rationality of curriculum length 4.0, 3.7, 3.9, 3.5, and 4.3. All of the perceptions and the satisfaction in cluster 1 are higher than all of the perceptions and satisfaction in cluster 2. You can see that, yeah. 4.2 compared to 3.4, 3.9 compared to 3.3, and so on. So what are the characteristics of cluster 1 and cluster 2 here? Can you say?
So I think that the characteristic of cluster 1 is like combine of people who the most satisfied in all factors.
Yeah, that's right. You can say that in cluster 1. Cluster 1 contains of the people who are who have the high perception with all aspects, right? And they are very much satisfied. In cluster 2, yeah, they are bad in all aspects and they are not very much satisfied in comparison to cluster 1. Well, this one, yeah, this is the best in according to SPS, you see. SPS suggests to you that, yeah, 2 clusters is the best number. But you see, it's very good in mathematical way, right? Mathematically, those 2 clusters are farthest to each other. They are most different to each other. It's mathematical way. But remember, we are doing marketing research. So if you use this to report to the managers, okay, we should have 2 clusters. Yeah, we should have 2 segments. The first segment is that people who are, yeah, let's say, who are good in all aspects with the university and very much satisfied. And the second cluster, people who are bad in all aspects with the university and not satisfied, then you get fired. Because this one, although very good in mathematical way, is not good in managerial way. No meaning in management, see? What we want is like this. What we want in management is that if we have 2 clusters, then you must say, yeah, for example, the first clusters, people who care about lecturers, subject complexity, and rationality of curriculum length. That's the first cluster. So if we target them, we improve lecturer, subject complexity, and rationality of curriculum length. Second cluster, people who care about facility, career development, location, environment. So if we target the second cluster, then we must improve facility, career development, and location environment. We need that. We need to know the difference in aspects that, yeah, cluster 1 care and cluster 2 care. See, we should know that. So we can try to target them with different policies. But if we say like this, yeah, cluster 1, people who are good with all aspects and satisfied. Cluster 2, people who are bad with all aspects and not satisfied, then how can we build policy for cluster 1 or cluster 2? We cannot build policies for them, right? So this one, very good in mathematical way, but meaningless in managerial way, okay? So you can see that, yeah, that's the gap between SBS and managers. SBS can suggest to you something based on mathematics. Managers, in another hand, need something based on management, okay? So what should we do? The only thing we should do is that, yeah, okay, SBS suggests to you 2 cluster, but very much pointless. So now we must try by hands. What about 3 clusters, right? Yeah. So go back to the data again. Go analyze, go classify, and key mean clusters. Well, 2 is useless already, so we try the 3, okay? Click OK. What if we try the 3 clusters? Look at the output again. This one is about 3 clusters. Now, where is that? Okay. No, this one is initial. Okay, final cluster here. Maybe I clicked the wrong button to delete. What about those 3 clusters? Here, I will show you how to interpret them. Now, first I take the screenshot, put it into PowerPoint, and I will show you. Let's delete all of things in PowerPoint first. Here, we have 3 clusters now in PowerPoint. I'll show you how I do this. Okay, the first thing, I rank them. In cluster 3, for that 3 is the highest in lecturers, right? So I rank number 1. Let's make this number 1 red, right? Red. How about subject complexity? Which one is highest? Still cluster 3, right? Rationality of curriculum's length, cluster 3, still the highest. Facility, that's right, cluster 3, highest. Career development, the same thing happened. Okay. Yeah, the same for location environment and the same for satisfaction also. So rank number 1 in all aspect. How about cluster 2? You can see that cluster 2 rank number 2 in lecturers. Yeah, subject complexity, the same thing happened. How about rationality of curriculum's length? The same thing, right? Same thing for facility. Same for career development, no. Okay, rank 1 in all aspect. In cluster 3, cluster 2, rank 2 in all aspect. Then we can see that cluster 1 will rank number 3 in all aspect, right? Okay. If we have this, what should we tell the managers? Well, again, you can see that this one is useless. If we divide our market into 3 segments, then the first segment is the segment of people who are very good in all aspects and very much satisfied. Second segment, people who are bad in all aspects of the universities and not satisfied. And the third segment contains the people who are middle in every aspect. Again, this one is not good at all. Yeah, not good at all. Because we cannot see the difference between the cluster in each aspect. See, it's always in all aspects. So this one is not good. Again, if it's not good again, then we must do the 4 segments. Okay, so you see this one, although very easy to run, is hard work for you and for me too. Here, number of clusters 4. What about 4 clusters? See, final cluster center here. Four. So say in lecturers, then rank 1 in number 3. 2, 3, 4, 1, 2, 3. Four. Oh, same thing again. 1, 2, 3, 4. Yeah, the same thing with facility. 1, 2, 3, 4. Right. Hey, a little bit different here. In career development, you can see that it's 1, 2, 2, 4. It's not 1, 2, 3, 4. It's 1, 2, 2, 4. What about location environment?
Teacher, if we do it like manually like that, then why do we need to do the hierarchy first? Why don't we start with
I told you that because it's in the book, yeah, hierarchical show you the best number of clusters, right? But in mathematical way, and I show you just to tell you that it's very much useless. Okay, but you must know how to do it. Useless, but you must know how to do it. Okay, so that's why I must show you. Oh, here, this one is 2 and this one is 3. It's a little bit different now. Okay, so with a little bit different, then you can see that how to talk about those 4 clusters. See, cluster 3 here contains the people good with all aspects and very much satisfied. See, and cluster 4 people who are bad in all aspects and very much not satisfied. How about cluster 2 and cluster 1? You can see that actually still hard to tell because cluster 2 is contains people who are better than cluster 3 in all aspect, but not satisfied. See, and in cluster 1, people who are, let's say, worse than cluster 2 in all aspect, but satisfied. So it's hard to tell which one really lead to the satisfaction. You see, if you use 4 clusters. So maybe I run the last one with 5 clusters and we can spot the difference between the clusters. This one you have no other ways of doing, only manually like this. And because the hierarchical is useless, you see. Okay, maybe this one is okay. So told you already, running the cluster is very, very easy, but required effort. This one is only for hardworking people. Now go to the PowerPoint. So in lecturers, which one is the highest? Cluster 1, right? 1. Then cluster 2, 1, 2. Then cluster 3, 3. Then cluster 5, 4. And then cluster 4, 5. How about subject complexity? 1. Subject complexity is a little bit different. Subject complexity 1. 2 is in cluster 3 and 3 in cluster 2. And then cluster 5 is 4 and cluster 4 is 5. Okay, that's subject complexity. And how about rationality of curriculum's length? This is the same with subject complexity. Right, this is the same with subject complexity. How about facility? Again, it's the same with subject complexity. Yeah. 5. Career development. Nearly the same, but no, it's not. It's 2 here too. 2, 2, 4, 5. How about location environment? No, this one is different. Location environment is very much different. Cluster 1 is still number 1, but number 2 is cluster 5. And then number 3 is cluster 3. Number 4 is cluster 4. And number 5 is cluster 2. 5. Okay. See a little bit different, and you will see how I make the difference between them. How about the last cluster? The last thing, satisfaction. 1, 2 here. 3 here. 4. Because 3 and 5. Okay. Okay. Now, let's stop here, and I will tell you about the characteristic of the clusters. Okay. What is the characteristic of cluster 1? Cluster 1 is people who are high in all aspects, right? And very much satisfaction. I will say that cluster 1 here, the segment 1 is the segment of easy. Students. Okay. Why I say they are easy? Because they have high perception on all aspects and they are satisfied. So I call them the segments of easy students. If we want to target them, what should we do? Well, actually, we do not need to do anything, right? Because they are very easy. They will get, let's say, satisfied with you, whatever you do. What about, let's say, cluster 4 here? In contradiction to cluster 1, you can see that in cluster 4, they are very strict. So I call them strict students in cluster 4. You can see that they score rank number 5 in all aspects. I mean, that very low in all aspects. This one is location environment is rank number 4, but actually it's still the same, right? Yeah. So they are strict students. If we want to target them, then we must improve everything from lecturers to location environment to get their satisfaction. Okay. What about cluster 2 here? Cluster 2, cluster 3, and cluster 5. I will compare them together. We will not talk about cluster 1 and cluster 4 anymore. So you can see that, yeah, let's talk about cluster 2 first. Now look at cluster 2 and spot something there. You can see that their satisfaction is okay, very much okay, you see. Oh, no, cannot draw very good here. Satisfaction is high because it's rank number 2, see, only lower than easy students, but we do not care about easy student anymore. So it's good here. Yeah, let's make it rank number 2, high satisfaction. Now what drives this satisfaction? High satisfaction. And you can see that is high in lecturers too, see? Because high in lecturers, because the rank is rank number 2. It is very high there. And high in career development, see? Medium in subject complexity, medium in rationality of curriculum length, medium in facility. So medium can be high or can be low, okay? They are okay. So okay in subject complexity, okay in rationality of curriculum length, okay in facility. High in satisfaction, high in lecturers, high in career development. Remember my model. My model is that lecturer, subject complexity, rationality of curriculum length, facility, career development, and location environment lead to satisfaction. So what about this cluster 2 here? What drives their satisfaction? You can see satisfaction here is high, lecturers is high, career development is high. So we can say that satisfaction satisfaction of cluster 2 driven by lecturers, driven by career development. Or maybe subject complexity, rationality of curriculum length, and facility too, because those are, let's say those are rank number 3. So rank number 3 can be called high or low. Yeah, up to you. But for me, rank number 3, but here 3.6, 3.5. So they are rather a little bit high, you see. So let's say, in summary, what really drives the satisfaction of people in cluster 2? You can see what really drives them in cluster 2 here. Lecturers, career development, subject complexity, rationality of curriculum length, facility. Okay, I would say that cluster 2 is the students who care about studying. Why do I think that they care about studying? Because they care about lecturers, because they care about career development, and maybe subject complexity, and maybe rationality of curriculum's length. What they don't care about is the location environment. Why? I think so. Because their satisfaction is high. Their perception about location environment is not high, right? But their satisfaction is still high. It means that they don't care about location environment. They care about lecturers. They care about career development. Means that they care about studying. Okay. Do you agree with me? So if we target them, if we target cluster 2 here, we must improve the lecturers and career development, and don't improve the location environment. See, perception on location environment is very low, but satisfaction is still high. Means that they don't care about location environment. Can you understand that? People?
Yes.
Okay. So now let's talk about cluster 5 here. What kind of people are there in cluster 5? You can see that, okay, rank number 4 on lecturers, subject complexity, rationality of curriculum's length, facility, and career development, all of them rank number 4. But let's care about satisfaction first. Satisfaction here is 3. It means that 3 here is average, right? But look at the absolute number of satisfaction is 4.1. This one is actually high. So let's say that is high in satisfaction, still high in satisfaction. Low in on lecturer, subject complexity, rationality of curriculum's length, facility, and career development. All of them are low. But look at location environment. It's called rank 2. Rank 2 means that high, okay? High in location environment, high in satisfaction. What does it mean? What kind of students are there in this? Okay, they are satisfied with only one thing. You can see only one thing. Location environment is high. All of the other things are low because rank number 4 on 5 is low, right? Low in lecturers, low in all aspects of studying, but very much satisfied because of only one thing, location environment. So those are students who care about location of university. So if we target them, we target the cluster 5, then we do not need to improve location, we do not need to improve lecturers or subject complexity or facility or whatever. We just try to make the location of the university better for them, and the environment around the university is good, so we will track them. See, those are people in cluster 5. What about people in cluster 2? Cluster 2. Cluster 2 here, you can see that their satisfaction is very low, see? Low satisfaction. Because rank number 4, see? 4 on 5 is low. Low satisfaction. Okay, high in lecturers. Lecturers is average, but 3.9, you can see that is a little bit high. Okay, so high in lecturers, high in subject complexity because rank number 2. High in rationality, curriculum's length, rank number 2. Facility, rank number 2. Career development, number 2. Means that they have high aspect in, in all aspect they are high, but their satisfaction is low. What happened here? high perception in all aspects, but low satisfaction. What does it mean? What drives their satisfaction? Can you tell me?
Maybe they like to
Yeah.
study.
Yeah. Again, please. Maybe what?
They don't like to study.
They don't like to study. What do they like? If they don't
Working.
like to study, they are not cluster 2, I say. But they don't even care about the location of university, you see. They are not even in cluster 5. What do they care about? Thank you, Kiyomi. That's very good. They care nothing in the model. Those that need more research. Because our model cannot explain their behavior, you see. I propose that lecturer subject complexity, rationality of curriculum length, facility, career development, location, environment. But those guys are not satisfied, although they have high aspects. Yeah, they have high in all aspects, but they are not satisfied. It means that they are driven by other things outside of the model. So I say this cluster needs more research. Okay. So now I have the characteristics for all 5 clusters. You see, yeah, easy student. If we target them, we do not need to do anything. They will be very easy to get into us. So how about cluster 2? If we target them, we must improve the aspects of studying, lecturers, career development, maybe subject complexity, rationality of curriculum length, and facility also. Okay, because they care about studying, make their study better, and they will flock to us. If we target cluster 3, we must do other research, see, further research to know what drives their satisfaction. If we focus on cluster 4, it means that we must improve everything because they care about everything. They are very strict. And if we target cluster 5, then we make the university easier for them to access. For example, move the university into their location, or maybe we only attract people around the university. And we try to improve the environment around the university, and we will have them. See? So characteristics and how to target them. I have all of them. Last thing to do is about the size of the clusters. You can see here that here we have cluster 1 and 156 of them. We divide it to 623, and we can see that cluster 1, cluster of easy students, they are around let's see, it's around 25% of the market. Okay, 25% of the market. Cluster 4 here, cluster of strict people. Okay, smaller. This one is less than 20, I think, because I don't have the calculator. This one is very easy. Divide it into 623, and then you know the percentage of them. And so, okay. Now you know how to make it, how to run the cluster analysis and analyze to know the characteristics of the clusters and the size of the cluster. Okay. Is there anything else you want to ask me about K-mean? Running is easy. Analyzing them is a little bit harder. Okay.
So in conclusion, I want to ask that when will we use the K-means?
Well, I think you should ask, when will we use the hierarchical? Because hierarchical is very much useless, you see. So if I ask you how many clusters that SVS suggests to you, then you use hierarchical. And when will you use the k-min? Then whenever you run the cluster analysis, you use the k-min. But we use a k-min, we must test 2 clusters, and can we get a meaning? Then 3 clusters, can we get a meaning? And 4, and then 5, and maybe then 6. But remember, the more clusters you have, okay, the more cluster you divide your sample into, the nearer they are to each other. And the nearer they are to each other, the harder it is for you to analyze. Okay. So do it carefully.
Okay, thank you, teacher.
Yeah, okay. Anything else, people?
So the analysis of the results is like different case by case, right?
Yeah,
Because
okay.
yeah, I see that it's not
But
really
normally you will try to first I would suggest that you eliminate the easy customers and strict customers outside of what you want to analyze. That's the first thing to do. Okay. There will be always easy customers and strict customers, and then you care about all the other clusters. Try to make the meaning, and the meaning here is what drive their satisfaction or what drive their purchase intention. Okay, try to see which one is with the same yeah, which one is with the positive relationship with the satisfaction, and which one with negative relationship. Just look at cluster 2 here. I work with cluster 2, and you can see that, yeah, first thing I care about is satisfaction, rank number 2. So this one is very good satisfaction. Then which of the aspects are also good, see. And then with cluster 5 here, still good satisfaction. Then which of them is still good? Then you can see what drives their satisfaction. The thing is with cluster 3 here, not good satisfaction. So I must look at, yeah, what are also not good, but none is not good. See, all of them are rather good, but they are rather good. Then what lead to the bad satisfaction? Nothing, right? Nothing. So I think they need more research to understand them. See, that's how I do the thing. You will do the same with your data, okay? You must do the same with your data. And then do not forget the last thing. How big are the segments, okay? Because maybe if, for example, cluster 2 here, you see students who care about studying, well, actually very good, because students should be studying, right? So yeah, students who care about studying. But what if the percentage of that segment is very low? Means that very little, yeah, very few students care about studying. Instead, they care about other things. What if that happened? Example here is 109. I don't know. Something very sad. You can see that cluster 5 here, 133 over 623 students do not care about study. They only care about the location environment of university, and the number of them is higher than cluster 2, higher than the students who care about studying. Oh my God. See, it is sad. Is that okay for you? Okay, then now the last one. Remember, try to understand what drives their satisfaction or what drives their purchase intention. Okay, now the last one. Go to classify. We have another thing called two-step cluster. Okay. Now, what is two-step cluster? This one is for lazy people. And of course, lazy people will get bad results. You know that already. Well, if you run two-step cluster analysis, then you put all of the variables you want into, you see continuous variables. Why continuous variable? Because those are intervals. Remember that those are metric are not continuous variable. Now, distance measurement. Of course, we use Euclidean. You know that already. Euclidean, and you click the AIC. Okay, do not use BIC. And number of cluster, you let it determine automatically. Now, how many cluster it will divide your sample into? Well, you guess. Click OK. Now I show you the result. Here, the result. You can see two-step cluster here. Number of cluster you see here is 2. Why 2? Well, because you know that already. The SPS suggests to you that 2 is the best. So if you run two-step cluster, it will give you 2 clusters because it's the best, right? SPS thinks that the best is 2. Now, if you double click it, then you will have this. And in the view model summary, and you do not need this. You click the clusters. It's better. Although it's better, you can see. Look at the clusters here. You can see that it shows you the mean of the clusters. But I say this one is pretty much useless too. Why? Because you look at the cluster size, you can see that cluster 1 and cluster 2 here, they are very much unbalanced. You see, the size of cluster 1 here is only 16 of them, and cluster 2 is 607. But anyway, you can see that if you divide into 2 clusters, it's very much useless. So two-step clusters. This one is for lazy people, and SPS will automatically decide the number of clusters and divide into clusters very unbalanced way. So if you use two-step cluster, is actually most of the time you will get the bad result. Okay, look at the cluster size here, unbalanced, very much unbalanced. So I just show you it. Do not use. Okay. Okay. Anything else you want to ask me, people?
So among the 3, we only use like the k-means that we.
Right. But if I ask you how many clusters are there in SPS aspect, SPS point of view, then you must run the hierarchical to know. Okay. But if you want to get a meaning for the managers, then you should use k-min and you test the number. Remember, do not test over 6 cluster because the more cluster, the harder for you to interpret.
Okay.
And the nearer they are, if you are lucky, then you get some meaning with only 3 clusters. If you are, let's say, normal people will get the meaning at 4 clusters. And if you get to 5, then you are a little bit unlucky. And if you must get 6 clusters, then you are very unlucky and do not get 7 because you cannot interpret anymore. They are too near to each other for you to interpret. Okay. Anything else, people?